Okay, so this is from number 3 and 5C, and we've got this car, starts from rest, sloped driveway, 20 degrees, doesn't matter which way your slope goes, you can do it either way. Average frictional force, so if we do a free body diagram, we have a frictional force. What do we know? Well, we know that work equals force distance cosine theta. We know that work equals delta KE. KE final minus KE initial. We know that work equals 1/2 mass final velocity squared minus 1/2 mass initial velocity squared, and that's 0. So what do we know? Net force times the distance it travels times the cosine theta equals 1/2 mass final velocity squared. The problem is the net force, isn't it? If only you had learned to do net force calculations someplace else in physics. Which axis is the motion occurring on? X. If we do our standard old tilted axis thing, could we figure out all the forces on the x-axis? Sum of force X equals net force. Net force equals, doesn't matter. I mean, I can draw it in. I can draw it in.
Oh, yeah, my bad.
Well, actually, it does matter. Or does it give us just the mass?
Yeah.
Yeah, okay. So, yeah, it does matter. I just hadn't gotten there yet. So, sum of forces on the x is the net force. Net force equals, well, we've got the force of gravity on the x minus the frictional force. They don't, I mean, obviously it's kinetic, but they're just saying frictional force, so we'll go with that. How do we find force of, we don't need the normal force, actually. How do we find the force of gravity on the x? Well, yep. So F net equals mass gravity sine theta minus frictional force. That should do it. Does that help? Does that address the question you had? If it didn't, say something. Twitch, throw something at me. I prefer muffins. Hearing no objections, we move on. That got it? Was it the force?
I thought that's what I did.
Okay.
But
Yeah, I can keep going.
I got like a completely wrong answer.
Okay. You're probably not the only one with the same complaint, so yeah, let's keep going. Let me shrink all this junk. Okay, we're looking for distance, right? Yeah, length of the driveway. Okay, so D equals MVF squared over 2 F net cosine. What's our cosine here? 0. Yeah, it's cosine of 0, so it's going to be 1. So we could technically get rid of that. I'm trying to think what the... Are you sure you squared... You sure you squared your velocity? So... It's our frictional force. 4 times 10 to the third, and that's just 1. Okay. No. that 4 times 10 to the third? Oh, hold on, I forgot my sine theta there, which is really messy and hard to read. I apologize. Let's try this again. Okay, so wrapping that up, we get 4.97, etc. Their sig figs are junk, so it's 5.0. Let's talk about number 5 real quickly. So for number 5, we've got a 10 kilogram crate pulled up a rough incline. Initial speed is given, so I'll go ahead and put VI is 1.5 meters per second. Angle with the horizontal is 15 degrees. Coefficient of friction is 0.4. Mu K equals 0.40. And it moves a distance of 7.5 meters. I obscured some of my stuff, but that's okay. We'll live with it. So we want to know, this is one, and this is an important one, work done by Earth's gravity on the crate, work done by friction on the crate, work done by the puller on the crate, and the change in kinetic energy as well as its final speed. So the first 3 pieces really are just designed to get you thinking in these terms and then to show you a trick. So force of the puller equals the work of the puller times d cosine theta, where cosine theta is the angle between the force and the motion. So we're going to have work of the puller. What's the force the puller is exerting? 100 newtons. 100.0 newtons times 7.5 meters. What's the angle between the puller's force and the direction that the crate is moving? Zero. It's puller's pulling it parallel to the incline. Yeah. Oh, is it? Okay. I don't know. Okay, so I guess I started with C. Sorry. We have to figure out all the work done by what? The polar gravity and friction? Okay. Okay. So this is cosine of 0. We'll go back. Is A gravity? A is gravity. Okay. Well, it just says gravity. You know that it's only going to be gravity on the x that's doing any work on it because that's the axis on which the motion is occurring. So work done by gravity will equal force of gravity, and we know it's on the x, times distance times cosine theta. In that case, what's the angle theta between the force of gravity and the direction of the motion? 180. So that's going to be cosine 180. So B is friction. Work done by friction is the force of friction times distance. Again, what's theta there? 180. Because that's moving in opposition to the motion. You all know how to get force of gravity on the x. Do you all know how to back your way into force of friction? Since they give you mu k. So mu k equals Fk over Fn. We want Fk, so mu k Fn equals Fk. And how do we find Fn? Oh no, we have to do sum of forces. So sum of forces on the y equals 0 equals Fn minus, I'm running out of space here, Fn minus mgy. So it would be mass gravity cosine theta, cosine 15. Is that okay? Do we need more conversation about that? Friction are both doing negative work, and this is that conversation we had on Friday. If you weren't here, you need to watch the video about negative work and cosine of 180. Okay, so everybody's good with parts D and E? Okay, because I was going to say, I can show you a quick trick there. So when they say that they want delta KE, we know that delta KE equals work net, and we know that work net equals force net d cosine theta. I'm doing a really bad job of the whole writing thing. You can go ahead and find the net force on the x-axis. You can also take all the work and add it up. Oh, because work works just like force. Where net force is the sum of forces, net work is the sum of work. So you can do that. You know, there are a bunch of ways to skin this particular little physics cat, though no actual cats will be harmed in the process. Speed of the crate after it's pulled 7.5 meters. Whoops, okay, let me do this. Net work equals 1/2 mvf squared minus 1/2 mvi squared, and we can solve for that because we already have a value for net work, which you got in part D. Questions, comments, concerns? Yeah.
You eventually hit the
Okay, so assuming no other questions, let's FIP you.